We're going to continue taking a look at this notion of tolerance. Want to work through one more example of that, and then we'll start tying that into the formal definition of a limit. So I've got a problem up here. In a moment, I'm going to have you pause the video and try to work this out. We're now supposing that we're manufacturing cubes that are the same length on each side. I'm calling that length x, and the volume is then x cubed. Okay. Our goal is to make the side length 2 centimeters, which would mean our goal for the volume is to have 8 cubic centimeters. Could imagine that we're manufacturing dice. That's something that comes in the form of a cube. These would be pretty big dice, but okay, we're manufacturing big dice. Okay, and I'm telling you what the tolerance is for volume. The tolerance is 0.1 cubic centimeter. And generally when you're given tolerance just in words, it's understood that that's the direction that you can go too high or too low. Sometimes you'll see the tolerance written as plus or minus 0.1 cubic centimeters. Sometimes you'll be just told that's the tolerance, but it's the tolerance in either direction. Okay, and so we want to find the tolerance for x. How far away from our target of 2 centimeters can we be in order to make sure that the volume is within 0.1 cubic centimeters? So I'm going to have you figure that out in a moment. I'm just going to get you started. I'm going to strongly suggest that you draw yourself a graph. So you'll have x and v of x. And the cubing function, and we're just looking at the part in quadrant 1, it actually looks very, very similar to what we had when we were working in the last example where we were working with the squaring function. Okay. We're concerned here with the point where x is 2, which would make the volume 8. If our tolerance is 0.1, that means we can go up to 8.1 or down to 7.9. But we want to ensure that we're in this section of the graph here so that the volume is where we want it to be. So your job is to sort of follow these lines down to see what are the x values that corresponds to these endpoints of where we're within that acceptable range of values, and then calculate these distances and pick the shorter one. Now, if you want to be a little bit strategically lazy, you can just calculate one of those distances. But you got to explain to me why you're doing it. Okay. So if you can explain, I can tell because of the nature of this graph that either the distance on the left or the distance on the right is going to be smaller, so that's the one I'm going to calculate, then you're fine just calculating that one. But do make sure that you write an explanation for why that's the one you're calculating. Don't just calculate one of them with no explanation, because then I'm going to think you forgot to do the other half of the problem. Okay, so go ahead and pause the video. See if you can find the tolerance for x. Okay, so if I follow these lines down, that's going to determine a point x1 to the left of 2 and x2 to the right of 2. And then I've got these two distances that I'm going to call d1. That's the distance that we can go to the left and still be within the acceptable range of volumes. And d2, that's the distance that we could go to the right and still be within the acceptable range of volumes. Now, I mentioned at the end of the last video, if we could figure out which of these was smaller, then we only need to calculate that one. And we can. This one is smaller because the graph is steeper to the right of 2. So the vertical distance, and I haven't drawn this perfectly to scale, but the vertical distance between an 8 and 8.1 and 8 and 7.9 is the same. Here where the graph is steeper, it's going to cover that vertical distance over a shorter horizontal distance. So I'm going to want to find D2, which means I'm going to want to find X2, this X value that's a little to the right of 2. And what I know is that x2 cubed is going to give me 8.1, because that's the point that I have on this graph of volume right here. And I know that that volume value is 8.1. So x2 is just the cube root of 8.1, which means d2 is just this horizontal distance. I'm going to take the right end point minus the left end point. So cube root of 8.1 minus 2, and that's my tolerance for x. And again, some people in talking about tolerance will just give you that positive value and let it be understood that's how much you can be off in either direction. Other times, and our book does tend to do this, they'll say the tolerance is plus or minus this number. I'm fine with you phrasing it either way, okay? I'm actually choosing to just give you that positive distance because that's going to line up more with what we do when we start talking about the formal definition of a limit, which is where we'll pick up in the next video.